In this video, we will learn transactions in your Apex code, its features, and not so obvious things related to its rollbacks and how you can manage it. And let's start by defining what a transaction is. This term is closely related to SQL transaction, where it's defined as a unit or sequence of work that you perform on a database. In the context of Salesforce, especially Apex code, the transaction is also kind of unit of work, or more precisely, it is a set of sequential lines of code that you execute at one time. Let's look at an example based on this sample code. We have created a controller method that marks related contacts as duplicates based on the first and last name. Not a big deal, right? This method also includes two calls to a private method right here at the top, as well as the method from another class that contains a so-called query to select those duplicated contacts. All the lines of code shown here are part of a single transaction. This includes all the method calls, whether they belong to the same class or a different one. Also, let's take a closer look at line 15. Here we save the contact changes to the database, and this line will perform not only the actual saving to the database, but also a large number of other operations, such as validation rules, triggers, flows. That is the entire set of order of executions that you can see on your screen right now. And all these deep processes, such as triggers when you update, create, delete record, etc., are also part of the same transaction. So really, by looking at an example, we can see that a transaction is a set of operations executed line by line, going as deep as necessary to execute all the code until there is nothing left to execute. This is important to understand because Salesforce imposes certain limits on your transaction, such as how many times you can update the record, the number of so-called queries within your transaction, etc. And as you might note, for this reason, there are rules of how you should organize your code, such as avoid so-called queries inside a loop, etc. This is because you can really easily exhaust that limit, and once that happens, your transaction will fail and roll back. Rollback. What the hell does it mean? Let's look at the previous example again and try to understand the concept of rollback. As we already defined, we are now looking at a single transaction that starts on the first line of code and ends on the last one. If we had another method call here at the end, then the end of the transaction would be the last line in that method. Remember, as deep as necessary. So in this method, let's try to identify those lines of code that could potentially throw an exception. This would be the first two lines here in case the first name or last name parameters are empty, and also the code could fail on line 15, for example, due to a validation rule. In all of these cases, if they really fail and you don't catch your exception with a try catch statement, they will roll back your transaction, which means that all the changes to all the data you made will be undone, and Salesforce will act as if the transaction never existed. That's what the rollback means. This concept is again closely intertwined with SQL transactions, where a transaction is described by four properties, ISID, and these properties are also applied to your Apex code. They stand for atomicity, consistency, isolation, and durability. Atomicity means that your transaction is one continuous element, and there should not be scenario when some half of the data is saved to the database and some is not. In other words, all or nothing. Consistency in the context of Salesforce would be a good idea to rename to say validation, because this property says that no transaction should compromise your data. For example, if you have a validation that the price for a product cannot be negative, then no transaction should have a benefit to bypass this rule. Isolation is explained by the fact that each transaction should be invisible until it's completely committed. That is, if you have a transaction that updates contacts first, then accounts, then cases, and even though the code is executed sequentially, all changes will be visible only after the transaction is completed. And durability property is probably the least related to what you should worry about. It says that once your transaction has successfully completed and changes have been made to the database, then even if the Salesforce servers are globally crashed, all the changes will be saved and not affected in any way. That said, going back to the definition of rollback, it is about this all or nothing. Namely, if your transaction fails, everything in this transaction must be undone. But since we're talking about Apex now, it allows us intentionally break some of these ASID principles. For example, the database class allows us to create, update, delete records partially. That is, commit to the database what passed successfully and not commit the records that failed. This is already partial work that doesn't really fit into the concept of all or nothing, right? So the idea is that these principles are undoubtedly important, but strictly enforcing them could cause you and me headaches, so Apex transactions are much more friendly in this case. However, this friendly behavior is definitely not the case with the Apex rollbacks. We often don't really think about how it actually works, and we especially don't take into account such a thing as the call stack. So let's see what it is and how it can be your biggest enemy when working with Apex rollbacks. The call stack, also known as the execution stack, program stack, control stack, runtime stack, or machine stack is such a container that stores the sequence of method calls, or more precisely, the depth of method calls. And to better understand this, let's go back to our favorite example right away, and here on the side we will draw our call stack container and try to see what it stores after each line of code. So the first line of code to be executed is the call to the mark duplicates contact method. This is the first method that will be called and from which the transaction will start. And this method will be the first one to be placed in our call stack container like that. After that, we go inside and call the method validate not null or empty. This call causes another block to be placed in our call stack container on top of the previous method, like displaying the depth of calls. As soon as this method is successfully executed, let's assume it has no exceptions, then the execution of the code returns back to the main method, and this return causes the removal of this method from the call stack, since it has already been executed. The same case occurs with the second call to the same method. Here it doesn't really matter that this is the same method, it follows the same rules. It is first placed in the call stack container, and after completion it's being removed from there. After that, we have a line to initialize the contact selector class. This initialization will cause the execution of the contact selector constructor, which will also be placed in the call stack, executed, and removed from there. And this idea will continue for each line of code in your transaction. Many don't really understand the purpose of this, but don't forget that your programming languages is not a piece of magic, it's algorithm and code, and this is how it keeps references. The reason I say this is that for Apex this understanding is critical, because if you don't understand it correctly, you will never fully understand rollbacks. Now let's look at a more complex example and look at the line 15. This update operation calls the entire set of execution, you remember that? And for simplicity, we will consider only the after update trigger for now. That is, we go to the trigger and as a result we put a new block in our container. Our trigger has a call to two methods. First we call the method update company duplicate contact, so we call this method and put another block in our call stack container while keeping the trigger itself since it has not yet been executed. After executing this method, we remove this method from the call stack and return back to the trigger, where we call another method and also put it in the call stack, and after execution we return back to the trigger and remove this method. After which we see that there is nothing more here to execute, so we go back to our main method and remove the trigger from the container as well. This is how the call stack works and allows Apex to understand where to return after each method completed. Now let's talk about something more interesting. What happens if one of these methods fail? Namely, we will rebuild the call stack again, starting with the main method, then the trigger, and then the triggers method. What happens if the send contact, the duplication notification method, fails for some reason? When this happens, a rollback point will be created and it will start its journey along the stack. Initially, the exception occurs in the send contact the duplication notification method, so this is where the rollback point is created. It then checks if there is a trackage block in this method to handle the exception. If there is not, it moves down the stack to the next method, in this case the trigger, and checks for a trackage block there. If we don't have trackage block here as well, it moves down to the main method and checks for a trackage block over there. If no trackage block is found at any level, it officially notifies Salesforce that a full rollback of all changes is required. That is, at this stage we understand that a call stack is the journey that your exception will take towards a complete rollback of all changes in the transaction. Now let's try to catch our exception. Go to the trigger and add a trackage block statement for our two methods right here. And in the catch block, I log the error to a custom logger and throw the exception again. This scenario will cause the rollback point to see that it's caught in the trigger, and in this case it will not move down the stack, but will die at this trackage point. However, since we added another exception, a new rollback point will be created from the trigger this time that will continue the movement and still cause a rollback of your entire transaction. I mean, this is expected behavior, since the idea is that we want to log the error first and only then roll back the transaction. But what if it doesn't? What if the requirement is that if any of this method fail, we don't want to roll back the transaction, but let it finish successfully? Doesn't sound like a problem, right? Let's just remove a new exception here, and then the exceptions that will be returned from the send contact the duplication notification method will die at this point, and then no rollback will happen. That's true, but here we run into an unexpected problem. Let's say that the update company duplicate contacts method finished successfully and updated the company details, after which the send contact the duplication notification method right here failed, and we ended up in this catch block. And instead of letting the exception continue its path, we killed it right here by not throwing a new exception. In that case, no rollback has happened, right? Because we coded the exception, which means that all the changes made by the update company duplicate method, I mean the first one, will be successfully saved after the transaction ends. That is, in fact, with this approach we can completely corrupt the data we have, because some information we will store, some we will not, and it's already a mess. Here of course the question is the design of your code and how deep it is. That is, if a method with depth 10 returns an exception, are you sure that the 9 previous levels will not catch this exception? But what if they will? So the idea is that there is only one single scenario when the rollback occurs, namely if you don't catch your exception at all, it goes to the first method in the call stack and causes a full rollback of all changes you made. However, if you do catch your exception and don't create a new one, at any point the rollback won't happen, and it doesn't matter how many methods you have in that try-catch block. You're not combining your code into one unit, you're just telling exception to go to the catch block, but it doesn't affect in any way any other methods in your try-catch block, right? Now, I'll talk about a solution for this problem. When we want, in case of an exception, only part of the code to be rolled back, but the transaction itself to complete successfully. For this, you have a tool in the form of a database class and two methods, Savepoint and Rollback. In fact, these are tools for you to create so-called local transactions in your main transaction. So let's try to apply it right away. In the trigger, before calling the two methods, we will create a so-called Savepoint using the database set Savepoint and assign it to some name, let it be unit1. In this way, we tell Salesforce that our local or internal transaction called unit1 begins right here, and after that in the catch block we use the method database rollback unit1 to roll back our local transaction like that. And in this case, if the second method fails and returns an exception to us in this catch block, we will also cancel the changes that were made in the first method. That is, in fact, we have combined these two methods into one single unit and they now work as one. I know some people give examples of those save points from games, when you save a certain point and reborn when you die, but I believe the idea with the made and eternal transaction sounds a bit more technical. We definitely didn't cover everything. We didn't talk about an asynchronous process, we didn't talk about uncatchable exceptions, and in general, let me know in the comments if you're interested in a specific topic. But for now, thanks for watching and I'll see you anytime soon.